And this is the second class of vital statistics. Today, first I discuss specific death rate, in short we denote it by SPR, SDR. A specific death rate or SDR is a death rate computed for a specific segment of community. So, a SDR is given by SDR equal to total number of deaths in a specific segment of the given population during the period in the given region divided by total number of persons in that specific segment of the population in the given period in the given region. Into 100, sorry, 10,000. Death rates may be made specific with respect to age, sex, occupation, place of dwelling, etc., or a combination of some of these factors. But generally, they are made specific with respect to age, sex, and combination of age and sex. The most important type specific death rates are 1. ASDR, that is age specific death rate. A stands for age specific death rate. Second, SSDR, that is sex specific death rate. And thirdly, specific death rate for both age and sex. First, I will discuss HDR, age specific death rate. What do you mean by age specific death rate? Age specific death rate for age group is dr for age group x to x plus n is ndx npx into 1000, where this ndx stands for the number of deaths between age x to x plus n minus 1 last birth day, and npx stands for the number of person in the same age group in the given period in the given region. And it is denoted by NMX. NMX is a age specific death rate for age group x to x plus n, and this is equal to ndx by npx into 1000, where ndx is a number of deaths between age x to x plus n minus 1 last birth day, and npx is a number of persons in the same age group in the given period in the given region. Now define annual age specific death rate and it is defined as dx by px into 1000, where this dx is the number of deaths among persons age x last birthday, and this px this is stands for number of persons aged x last birthday, and we denote this by simply mx. So mx is a annual age specific death rate, and it is defined as dx by px into 1000, where dx is a number of deaths among persons aged x last birthday, and px, which is denoted by number of persons aged x last birthday. And if we construct a table for 5 years age group, Then first column is age group x to x plus 4. Second column 5 dx, since here n is a 5. Third column 5 px, and fourth column is age specific death rate, that is 5 mx equal to 5 dx 5 px into 1000, and the entries are 0 to 4, 5 to 9, 10 to 14, 15 to 19, 20 to 24, and so on. And if you collect the data 5dx corresponding this age group, and then you need to put this value here, similarly for this value, and then we get 5 mx. Just this is the ratio between these two into 1000. Similarly, we need to collect this data for this interval, for this interval, for this interval, and so on. So in that way we compute specific death rate, each specific death rate. And here I want to mention that this stands for population of age x to x plus 4 last birthday, and this is total number of death among age x to x plus 4 last birthday, and 5 mx stands for age specific death rate for x to x plus 4 last birthday. Similarly, we can define age specific death rate for 10 years age group. Now the next point is sex specific death rate. SSDR, the sex specific death rate defined as follows: MM, this is specific death rate for male, and MF, I think it is better to write in that way. This M stands for male and this for specific death rate, and this is for female, prefix F in prefix FM, specific death rate for female. So I erase this portion fast. So specific death rate for male. This is M for male into X into 100,000. So this is stands for M in X. This is a total number of death, male death of age X to X plus N last birthday, and this is a total number of male population of age X to X plus N last birthday, and this is a specific death rate for male of age group in X to X plus N. Similarly, we defined age specific death rate for female, and we denote this age specific death rate for female as follows, and this is the ratio between, this is F NX. This stands for total number of female death between age group X to X plus N and total population, female population between age group X to X plus N into 1000. This is a specific death rate for female. Now the advantage or merit for this specific death rate are the true and the best measures of mortality, because they give more detailed information regarding the mortality pattern of the community than the CDR, because age specific death rate considered age, or sex specific death rate considers sex, but in CDR we do not consider such thing. Since in the case of SDR specific death rate, especially age specific death rate, we have for different rates more or less homogeneous groups. That is, groups are such that for all the members of a group, the mortality may be supposed to be about the same. The SDRs are more meaningful measures of mortality than CDR. For the same reason, it is more appropriate to give a probability interpretation to the SDRs than CDR, that is the probability that a person of a certain specified time will die within the given period. The next advantage is specificity by age and sex, eliminating differences in the death rates arising from variation in population compositions in respect of these characters. To this extent, such SDRs can be compared from one community to another community. That is, SDRs provide more appropriate measures of relative mortality situation in the region. And the disadvantage or demerits are computation of SDRs requires very elaborate data. For example, to obtain SDR, age specific death rate, the distribution of death as well as the population by age and sex must be available. There will be a big mass of data where one obtains specific death rates, specificity being achieved with respect to age, sex, etc., or some combination of these factors, that is age and sex. The significance of such data may be difficult to get. The comparisons of mortality labels of two regions for the same period or those of the two periods for the same region with the help of SDRs may not be easy. It may so happen that one region has higher rates than the other for some segments while lower rates for other segments. In such cases, one cannot say which of two regions has higher overall mortality. That is, I want to say, it may not happen that one region has higher rates than the other for some segments, some age groups, while lower rates for other segments. In such cases, one cannot say which of two regions has higher overall mortality. Now consider some remark. Remark 1. If mx, if nmx is the death rate for age group, this is the death rate for or at age group x to x plus n, pnx, population in the same age group, that is x to x plus n, the total death will be this is a total death, then crude death rate equal to total death means this divided by total population, considering all age groups. Clearly, the value of NPX are increased for older age at the expense of the younger age, then not with the standing the consistency of age rates of mortality, the CDR will rise. The weights used in such an average are therefore important. Consider the CDRs for community A, we denote it by MA, and this should be, if you use this formula, NMXA, this is a death rate for community A at age x to x plus n, and this is total population in that community for that age group divided by NPXA, and this is the CDR for community A. Similarly, for community B, we denote it by MB, and it should be NMXB NPXB divided by npxp. Even when two community have same mortality situation at different age group, then this MA and MB may be unequal, because the proportions, we write this portion as I mean to say and these portions written as now. Even if this and these portions are same, that is for all age group, even if this MA not equal to MB, because this portion may not be same. So hence CDR cannot be used to compare mortality situation. For that reason, we cannot use CDR to compare mortality situations in different places unless the population of the places have identical age distributions or sex distribution, a condition which is seldom fulfilled. Hence, in that situation, we consider age-specific death rate to compare mortality of two different situations, for two different situations. Now, relations between CDR and SDR. CDR equal to V by P again. SDR, this is equal to and dx is equal to mx into px. Therefore, CDR equal to mx px, that is replace dx by mx into px divided by px, and we write this as this. So this is the weight where Wx is equal to px by summation px and summation Wx is equal to 1. Hence, this is a CDR is nothing but a weighted average of SDRs where Px by sum over Px is the weight. Now we see that SDR shows a shrinking behavior for communities in general. The SDRs start at a rather high level in first year. It looks like SDR that is high level, then low, again high. So start at rather high level in first year of life, then gradually diminish and reach a minimum, then again rise slowly until midlife. This is midlife, and then rise rapidly at the older age. Rise rapidly at the older age. So midlife, this is slow, this is midlife, and then for older age it increases rapidly. So if you draw the curve age versus SDR, then it's look like this. Yes. So the curve with SDR along y-axis and age along x-axis is roughly U-shaped or both tube-shaped curve. Now consider the next point, that is standardized death rate. In short, we denote it STDR, S for standardized, ST for standardized, D for death, R for rate. In order to get a clear insight into the mortality situations of two communities or even of the same community over two different time periods, it is necessary to make comparisons of death rates according to the different characteristics such as age, sex, etc. However, it is difficult mentally to assimilate a large number of rates, and for many purposes one series may have higher specific death rates than other for same sections but lower SDRs for other sections, which I already discussed in disadvantage stage. Disadvantage of SDRs, in the section of the disadvantage of SDRs. In such a case, we cannot make a general statement of the form mortality is higher or lower in community A than community B. Hence, in many purposes, it is desirable to have a summary measure to describe the whole experience. Because of these facts, it is desirable to have a single figure index, some sort of average of the death rates for various section of population. First, I will discuss direct standardizations. The simplest single figure index of this type, CDR, because CDR is nothing but a summation in mx npx npx, but it suffers from the defect that it is greatly influenced by the weights with its distribution of locality. To eliminate the defect, it used CDR. An index is constructed with the same standard weights, that is same set of weights for two community. This is done by considering a third population. See, I already mentioned this thing, this weight. This is very much influenced by this portion is, even if this same, this portion is very much influenced by communities. So even if these are same for two communities, because if these two are not same, these weights are not same for two community, CDR for community A or community B are not same. And since this varies, these weights are varies community to different age group, so we cannot say overall CDR of A is better than CDR of community B. Similarly, for community A, B is better than community A, because these are not fixed for all age group, these weights. So for this reason, we consider standard weights, and this standard weights is obtained from or calculated by using standard populations, and this standard population is a third populations. This is apart from this population A and population B, and here we denote NPXS is a number of persons in the age group X2, X plus N minus 1 last birthday in the standard population. Then age as the adjusted death rate or age standardized death rate, STDR, is NMX. Replace this by NPXS divided by summation NPXS over all age group, where NPXS by NPXS are the weights for age group x to x plus n minus 1. This age adjusted death rate is the CDR which would be observed in the standard population if it experienced the age specific death rates of the community in question. A death rate may be adjusted for characters other than age and may be similarly interpreted for in case the death rate for A are specific for both age and sex, the STDR A for community A, if we consider age and sex, M for male, this is age from x to x plus n minus 1. This is for female. Now, the advantages of this STDR is easy to compute and is also easy to interpret. If the age specific death rates of one community are higher than of another, the fact would get reflected in adjusted death rate, and these disadvantages are: one drawback of considering adjusted death rate as a reliable index is the subjective considerations in the choice of standard population. If the standard population does not vary too much in its age distributions from those of the community compared, then the difficulty may not be great. The usual procedure is to take as a standard the actual population of the bigger community of which A and B are part. In some studies are uses the ratio of STDRA and CDRS as an index of mortality called comparative mortality factor, and it is for, suppose for region A, this is nothing but a sum over x all age group. So this is nothing but a this whole divided by a similar index is the weighted harmonic average of the ratios mxa by mxs, the weights being the death figures for the given population. It is called the standardized mortality SMF Thus, SMF for region A, because here we consider harmonic average of the ratio mxa by mfs as a weight, so this should be here it is arithmetic and it is a harmonic mean. Sorry, this should be S, and this is equal to y. Now the next point is indirect standardizations. The direct standardizations involves NMX, the age specific death rate for community, as well as NPX S, which is a age specific distribution of standard population. When NMX are not available, the direct method cannot be used, and then we use indirect method. Suppose the only total number of deaths and hence CDR is known for community, and suppose C is a adjustment factor, then CDR into C equal to STDR, and CDR is nothing but a NMXA NPXA for region A, and this is equal to then the factor C is nothing but a sorry A. But this factor C cannot evaluate it with the type of data we have in hand, since this NMXA is unknown. So we replace this NMXA by NMXS because we assume that this is known for standard population. Then it should be NMXS NPXS by NP summation NPXS by summation NMXS, that is, I want to say, I write this thing. If you replace this, then you get summation nmxs npxs by sum over npxs by all divided by nmxs npn npxs, sorry, this is a for region A, by npxa, and corresponding, and but this factor c cannot be evaluated for this reason. Sorry, actually I want to say, since this is unknown, we replace this by nmxs and we denote this value by c1, and the corresponding stdr, the corresponding stdr is c1. Instead of c, we use c1 into cdr. Generally so this, that's why this is called indirect standardizations, and generally the indirect method gives almost the same value of stdr as a standard method would if ASDRs of a given population are proportional to SDRs of standard population. Then two methods are exactly equal to each other. Because if mxa is proportional to mxs for all x, then we see that if you replace mxxa by k into mxs, where k is a proportional constant, then we get cdr, we see that c and c1 are same, therefore we get the same value for stdr using direct or indirect method, direct and indirect method. Next, comparative mortality index. The populations are at the start of the period been taken as standard in computations of STDR or the CMF, which CMF is comparative mortality index. Sorry. CMI. The population at the start of the period been taken standard incomplete STDR, which gives rise to difficulties in making a comparisons of mortality over time for the age sex distributions of current population may be widely different from that of the standard, so STDR values give an unrealistic picture. To meet this objection, the Comparative Mortality Index CMI has been introduced to meet this objection or overcome this objection. Here use is made of a shifting set of weights in taking weighted average of STDRs. We use shifting set of weights in taking a weighted average of STDRs. Thus, the CMI for a given period will be given by where Wx is equal to and Px is this Px is being the population figures at age x for standard populations, and Px, this is given period, population of given period, and Mxs is a STDRs for standard population of age group at age x, and Mx is a STDRs at age x for given for the periods. We may require to compare the mortality of a community in successive years. This may be achieved by forming rates of the corresponding CMIs. Cause of death rate. The crude cause of death rate for cause A denoted by MC, this is equal to DC by P into 1 lakh, where DC stands for total number of deaths from causes C occurring in the cause C occurring in the given period in the given community, and P stands for total population of the given community in the given period. This rate has the multiplier 1 lakh instead of 1000 in order that in many given case the computed rate does not appear as a small fractions. This rate is used to measure the contribution to the total mortality of a community that is made by specified cause of death, say a specific disease or accident. Use. This is the measure that serves as the basis for many public health programs to reduce deaths from the cause, and also as an index of success or failure of such health programs. And its merits, first merits, it has a simple interpretation because it gives the number of persons per lakh people dying from the cause C during the given period in a given region. 2. It is also simple to calculate, although it is not as simple as CDR. Third point, it is a measure of reductions of the population as a whole from the given cause, and its drawbacks are it cannot be used to compare the mortality situations due a cause of death for different community, since it does not take into account the age sex compositions of the community. Second point, cause of death being subject to the great degree of reporting errors, the computed rate is absolutely to be unreliable. And last point, it is not a probability rate for the whole population. For the whole population may not always be regarded as the population exposed to the risks of death from a given cause. This is the last point which I am going to discuss for this class. Then I stop this class for that day, for this day. So this is a maternal mortality rate, MMR. This is denoted by MP. This is a ratio between DP by B by into 1000, where this DP denotes number of deaths from peripheral causes among the female populations, and B denotes the number of live births occurring in the given period in a given community respectively. So this DP is a number of births. Again I repeat, this thing DP is a number of deaths from peripheral causes among the female populations, and this is number of live births occurring in a given period in a given community. The rate is intended to measure the proportion of mother deaths from peripheral causes among the female population that goes through conceptions sometimes during the period. The part of the female population that goes through conceptions sometime during the period and not the whole population is exposed to the risks of dying from peripheral causes, that is cause relating to the childbirth. This population may be approximated by the number of mothers giving birth to live born children plus the number of those delivered dead fetus. But the fetal deaths are almost universally poorly registered, and most countries maintain data not on the number of mothers, rather on the number of living live birth. These are the reason why maternal mortality rate has as its denominator of the number of live births. The drawbacks are, firstly, peripheral causes of death are generally subject to a large margin of reporting errors. Secondly, the live births are generally under registered than maternal deaths. As such, a maternal mortality rate will tend to the overstated to some events. Thirdly, it is not a probability rate. It may be noted that only the part of the female population that experience and conceptions sometime during the given period that not the whole population is exposed to the risks of death from the peripheral cause. So this is the all about for today class. Next class I will discuss life table. Till then, please stay with us. Thank you.